Hey guys, I had some technical difficulties and so I had to split this into two videos. But we're talking about elimination now for systems of equations. And as you notice right here, what we're going to do is combine these two equations and try to cancel out either the x or the y so that we can more easily solve. So we had a negative 4x minus 7y and then a positive 4x plus 2y. And if you add these two equations together, these will cancel. So what we're going to have is these cancel, and then, excuse me, negative 5y, and then negative 10. Alright? And then we will divide by negative 5, divide by negative 5. Y is going to equal a positive 2, and that's one of our answers. Okay? And then we will need to just pick one of the equations, whichever one looks prettier to you. I'm actually going to choose the second one, and I'm going to plug in 2 for y. It's going to look like this. 4x plus 2 times 2 equals 8. So 4x plus 4 equals 8, minus 4 minus 4. 4x equals 4, and x is going to equal 1. You need to divide by 4 on both sides. Okay, so now we have our two answers. Y is 2, x is 1, and we can move on. Number 6. Alright, we need to make these similar. Alright, we need the x's to match up, the y's to match up, and the numbers to match up. So I'm actually going to switch them around and make them make this second one look just like the first one. So what I'm going to do is I can actually just invert this and put them on either side of each other, just flip these equations. So when I rewrite it, I'll leave this one, 9y plus 29 equals negative 2x. And then when I flip this equation, got negative 9y minus 26 equals negative x. Okay, so it's kind of up to you. What you could do is you can add x on both sides and add these, move them over here, and change every single one of their signs. Or I just flipped the equation over so that the x's would match, the numbers would match, and the y would match. And then, like this, what I can do is I can combine both equations. So I will add these, so those cancel out. And then I will end up with a positive 3 and a negative 3x. Divide by negative 3, divide by negative 3. And x is going to equal negative 1. Okay, then once we have the x value, I'm going to take this x value, and I'm going to plug it in right there. So I have a negative 1 equals negative 26 minus 9y, and now we can solve for y. This becomes a positive 1, negative 26 minus 9y. Going to add 26, add 26, 27 equals negative 9y. Divide by negative 9, divide by negative 9, and negative 3 is what y equals. So we have the x and the y value, and we can move on. Alright, now I'm looking at number 7. I need one of these to match, either the x value or the y value. If I look at this, I can notice that if I multiply this equation by 2, then these would match, to where this would be 12x, this would be negative 12x. When we add the equations, they would cross out, and it would work beautifully. So what I'm going to do is rewrite these the exact same way they were. 12x plus 2y equals 10. So this is just that same equation. And then I'm going to multiply this one by 2. Negative 12x minus 10y minus 50. So I multiplied each one of them by 2. And now we can add the equations. These will cancel out. So 2y minus 10, negative 8y. And then this becomes negative 40. Forgot my negative sign. Divide by negative 8, divide by negative 8. Y is going to be a positive 5. So there's one of my equations. And then I'm going to plug 5 in for y. 12x plus 2 times 5 equals 10. 12x plus 10 equals 10. Minus 10 on both sides. 12x equals 0. And then when we divide, we will get x equals 0. And that's perfectly fine to have that as an answer. It's not an issue at all. Alright, our last problem. So again, this one we want to rearrange. We want to make all the equations look the same. So I am just going to choose to make this equation, the top one, look like this one. So I want to leave 6x, or leave our x value on the left-hand side of the equation. So I'll leave that there, negative 7x. But then I want to move 4y to the right-hand side and move 28 to the right-hand side. So the way I do that is I subtract 4y on both sides, so minus 4y. And then I subtract 28 on both sides. Okay, so now these are my two equations. Got the 6x and negative 7y. I've got 9y, negative 4y, and then I've got my 24 and 28. So this one's kind of crazy because you're going to have to multiply both equations to be able to solve. And the way I do that is I can look and figure out, okay, what do I multiply this one by to make the same thing as that? And actually, the only thing that you could multiply this by is you'd have to multiply this top one by 7 to make the x's match up. Multiply the bottom ones by 6. I multiply this top equation by 7. 7 times 6 is 42x. 7 times 9 is 63y. And then 24 times 7 is a number that I don't know, so I'm going to have to look it up. 24 times 7 is 168. Alright, and then 6 times negative 7 is negative 42x. Okay, so that looks good because we'll be able to cancel those out. 6 times negative 4 is negative 24y. And then 6 times 28 is 168. So that's also 168. So that's nice. Alright, so I'm going to add both equations. We get 0 equals 63 minus 24, which is 39y. And then we are actually adding these, so make sure you see that these are not going to cancel out. Oh, actually, they are. Glad I caught that mistake. That is a negative 28. Okay, wonderful. Glad I caught that because this is going to be 0. Alright. So we basically now just 0 equals 39y. If we divide by 39, y is going to be 0. So that is nice. And then our equation, we can plug y 0 in for y for any of them. So I'm actually going to take this top equation and plug 0 in for y. I'll change pins. 4 times 0 minus 7x plus 28 equals 0. These will cancel out. Negative 7x plus 28 equals 0. I'm going to subtract 28 on both sides. Negative 7x, negative 28. Divide by 7, divide by 7. And x will be a positive 4. So you won't always end up with 0 for these, but you do in these cases. This is one where it may be easier for you to use substitution. I just wanted to show you guys that so that you could see that you could choose either one, but it can get a little crazy when the numbers don't match up well, and substitution may be easier for this. All right.